Okay, guys, let's go ahead and get started. That sounds a little loud. Hold on a second. Testing 1, 2. How's that? You guys hear me? You guys can hear me all right. It sounds funny in the background. Okay. Still sounds funny. Doesn't it sound echoey or something? A little bit. Let's see here. All right. How's that? That's a little better. Okay. So welcome Jesse and Saul, right? Okay. And at home today we've got Byron and Matt. Good morning, guys. How's everything going out there in cyberspace? Here we are on day 2, engineering survey. I put up my contact information up there for you again, jdpavlik@gmail.com if you have any questions at all about the exam or the material that we've covered. Please feel free to contact me. Just a reminder that every lecture that we do during the series is recorded live, and if you are not able to make the class, you can always watch it at your leisure. Good morning, come on in. Paul, right? Yep. Yeah, how you doing, Paul? So you can always watch the class at your leisure if you're out of town, if you're doing something else. Okay, so last week we had a great week, and I hope you had a great week in between. Mine was not so great. I ended up hurting my piriformis muscle. You know where that is? It's in your butt. So I injured it playing golf, and it's right next to the sciatic nerve, so it felt like I was being stabbed in the butt with a knife for like 3 days until I went to the chiropractor. So I'm okay now. I was a little worried about making class, but I'm fine. I'm gonna make it through. So anyways, last week we had a very productive Saturday, and we cover a lot of material. Remember, we're covering 2 books, the Engineering Survey Manual and the Surveying with Construction Applications. I think by now most of you realize that you do not need to buy this book. I think everybody had a pretty good understanding of everything we talked about last week, and that's good. That makes me feel good. That means I did a pretty good job. Okay, and that's what I'm here for. Okay, we also talked about some interesting topics: measurements, error theory, taping, leveling, coordinate system, bearings, and traverse calculations. We had 2 sets of homeworks to do. One, there's some problems in chapter 18, and another, there were some problems in chapter 17. The first thing we're going to do today is go over all of those homework problems in detail. And if you have any questions about the homework problems, we'll stop down and work it out. Okay? One of the things I asked you to do was watch the field demonstration DVD. Did everybody get a chance to do that? Okay, you have any questions about the field demonstration? Did the link work okay? Was the quality was pretty good? I still had brown hair back then, didn't I? I think that thing, it's not that old. It's probably 5 years old, maybe. And I think I was a little bit, I weighed a few more pounds as well. I looked at it the other day, I was like, wow, I think all this working out I did has been paying off. So anyways, that was a really good demonstration about all the equipment that we talk about in class. You got a chance to take a look at it. So today we're going to continue on our journey talking about engineering surveying and getting you ready for this examination. And we'll be talking about topographic surveying. Photogrammetry is just another way of doing a topographic survey, okay? That's all that it is. We're going to be talking about the GPS system, the Global Positioning System, and how we use it in land surveying. We're talking about GIS, the Geographic Information System, and what surveyors do in respect to GIS. And we're going to end up with talking about vertical and horizontal curves. We'll spend a little more time on vertical curves. Most of the people are more unfamiliar with vertical curves. They're a little more familiar with horizontal curves. If you took the PE Civil how many weeks is it now? Is it still 13? The previous? Anyways, the PE Civil Review, they actually spend a whole day on highway design, and they talk a lot about horizontal curves. So we'll spend a little more time on vertical curves than horizontal curves today. And then I'm going to assign some additional homework problems for you to do this coming week. And then next week we'll end up with public lands, legal descriptions, state plane coordinates, state law, construction surveying, staking, field practice, mass diagrams. And then you'll note that we have some additional homework problems there. We'll be going over those in class together. Okay, we're going to do that next week. For you, Jesse, you're not going to be attending. I would strongly suggest you do those homework problems on your own. And then when you watch the video, you can go, you'll get a lot more out of it that way, okay? You can do that after the football game and the tailgate party and all the rest of it. That's your alma mater, right? Okay, cool. Is it a homecoming thing?
No, it's at Wisconsin, so it's
Oh, I see. It's an away game. Okay. Okay, so that's what we have in store for the next 2 days. So let's go ahead and go over the homework problems to begin. And those are going to begin, the first ones are in chapter 18. And let's all turn to page 322 to begin. And just so you know, and you probably, I hope you figured this out by now, but the solutions to these are in the book, okay? The solutions begin on page 328. How many of you figured that out? Good. And the problem with having solutions in the book, it's kind of good and bad. One is if you get lazy, you can kind of go back and see, oh yeah, that's exactly how I would have done it. All right. And that's the bad part about it. The good part about it is sometimes you can look at the answer and kind of reverse engineer it and say, okay, this is how they did it, and now I understand. So it's good and bad in a way. You'll note that the problems that are in chapter 17, only the solution is shown. Only the answer is shown, not the solution. When we go over those, we are going to go over the solutions as well. In other words, how did we actually solve these problems? And I will be emailing you a copy of that solution sheet for the practice exam. It'll be in your inbox when you get home tonight. Okay. All right. Page 322. The first one says. And we're looking at the first problem here. And these problems were taken from this book, the Surveying with Construction Applications by Barry Cavanaugh. That's where these came from. And the first one says 100-foot ad tape. And remember, an ad tape is one that's only graduate in hundredths and tenths of a foot for the first what? 1 foot, okay? Only the first foot is fully graduated, and then every not every even foot, but every foot, incremental foot after that is calibrated. So in this way, 2 people are reading it. One person's on one end of the tape, one person's on the other. One person's going to read the foot, the other one will read the tenths and hundredths, all right? So sometimes when you're measuring, you might be on the wrong foot. So you'll hear the chainman say, give me a foot. What that means is I can't measure to the point anywhere within this 1 foot here, okay, because it's too short or too long. Or either take a foot or give me a foot, all right? So they'll do that. They'll either take one up or give one out. That's what that means. Okay, so basically all we're going to be doing here with an ad tape is adding the 2 measurements together. Okay, so we have a distance of 47 for the rear surveyor, and the head surveyor is 0.59. And if you'll look over on page 328, you'll see that's all that we have done. is added the two together. All right, so very, very simple there. We'll start off nice and slow. The next one, and remember I told you last week, when you're doing correction to taping distances, the first thing you want to tackle is what? What's the first thing that we want to take care of when we're doing a taping correction? Okay. Temperature correction, all right? We want to take care of that first. Okay, another rule of thumb, in case you forget that formula we talked about, and remember the formula was 0.5065, that's the coefficient of expansion for in-bar steel, times the difference in temperature between the standard temperature of the tape and the temperature of the air, times the length being measured, okay? If you forget that, another rule of thumb is for every 15 degrees delta T is going to equal 1/100th of a foot correction per 100-foot measured, okay? For every 15 degrees delta T, and we're talking about the difference between the standard temperature and the temperature of the air. And remember, if it's not given, the standardized temperature is not given, you should assume 68 degrees, okay? The problems in the book, I think there's a couple problems in the book where they don't actually give you the standardized temperature, so use 68 degrees. All right. So we've got a couple things going on here. The temperature is 57 degrees. The tape length is given, so we're measuring on a slope, okay? And when we do a survey measurement, what do we want to express that measurement in? Horizontal, slope, or vertical? Horizontally, right? The horizontal distance between the 2 points. So looking at page 328, you'll see the first thing we're going to do is do the temperature, 0.5065 times delta T times the length, okay? And remember, it's hot add, cold cut. So is the tape hot or cold? Cold, okay? So we have a correction then of 2/100ths of a foot. That's for the overall length. So the corrected slope distance is the next thing we're going to look at. So we're given the slope distance is 273.75. And then we're going to take the horizontal distance. The horizontal distance is the slope distance times the cosine of the slope angle is equal to 273.66. Okay, Matt, looks like you had a question there about temperature. All I'm seeing on the screen here is temp. So, all right, so Matthew at home has a question there, so we'll get caught up with him. Okay, any questions on that one? Okay, the next one is compute the corrected horizontal distance. The temperature is 93 degrees Fahrenheit. The tape length is 100.02. Okay, Matt. Matt was just answering a question from me, so that's good. And by the way, Matt, that was the correct answer. He said, what should we correct for? When I asked the question, what should we correct for first? Matt said temperature. Okay, so the elevation difference is given and also the slope measurement is given. All right, so we've got the next problem here. We're going to correct for temperature first. And it's a hot tape, so we're going to add. So we end up with 1300 C sub T, correction for temperature. And then the correction for length. Okay, the correction for length. The length of the tape is supposed to be 100 feet, but is it 100 feet? It's actually 100.02. For some reason, it's longer than it's supposed to be. All right, so it's actually stretched, so it's just